let's continue. Right, you take a break, you get right back into it. So this question, we're going to some multiple choice now. Which of the following sequence represents the steps of problem solving in the correct order? Right? The correct order is what? Remember, we define the problem, we propose or evaluate solutions, we determine which of those are the most efficient solution, represent the solution as an algorithm, and then we test and validate the algorithm. So which one of these would be the correct answer? We develop an algorithm. No, we don't develop an algorithm. So this one, we would even consider this one. Propose and evaluate solution. No. Define the problem. Now we're talking. Define the problem. But C and D have defined the problem. So which one is it? After they define the problem, you propose and evaluate solution. Yes. Yes. You determine the most efficient solution. Yes. Develop an algorithm. Yes. And test. Yes. So we will go with this answer. A problem can be broken down into 4 significant parts. What are they? Right? Remember? What are they? We know input is one of them. So input, this is not one of them. Throughput. So A is not is the answer. Input is a significant part. Process, yes. Output, yes, and storage. So this one. Which of the following is not a good feature of an algorithm? Not a good feature. We say an algorithm, so should be clear. It should be precise. Have take a finite number of steps. Have a single stop. Readable. So we're looking at these. So we know, yes, a good feature is to show the number of steps, show the sequence, yes. Can be interpreted in many different ways. I would say no. So this one is not, 90% says not a good feature. Moving on. Later. Identify, let's zoom in for this question, make sure we're seeing clearly what the question is, right? Identify the arithmetic or relational. Identify the arithmetic or relational operator used in each of the following statements. An error code must be 3 digits. An error code must be 3 digits. So error code must be 3 digits. So we are saying that the error code, whatever it is, must be, and we're going to say must be equal to 3 digits. So the operator will be equal. The cashier deducted $2 for the sale item. She deducted $2. And we know deducted means subtraction. So that would be a subtraction. There are 2 more passengers in the car. 2 more passengers. So we say that's an addition. All right, let me fix that. That looks kind of wonky. So it's a addition. Right. There must be 15 or more passengers on board. There must be 15 or more. So we know or more is greater than. So it's going to be greater than or equal to. There must be 15 or more. Next one, for the following statements, use relational operators. The first one is done for you. There are 3 sisters, right? So this one showing that sisters equal 3. B, citizens must be at least 18 in order to obtain a picture ID. So we talk about at least. We're talking about so citizens must be at least 18 years old in order to obtain a picture ID. When we talk about at least, we're saying the smallest number must be 18. So it would be greater than or equal to 18. So we're talking about age. So the variable would be age. There are 7 students with passes at grade 11. At grade 2, sorry. So 7 students with passes at grade 2. So we would say this is going to be equal. So it's going to be equal to 7. And we're going to call that variable. We could call it passes. We could call it students. I would say passes. Right? Forgive me. I'm trying to. Let me fix that. Let me use the text box. So passes equal to 7. Employees have at most 4 weeks of vacation. At most 4 weeks means it is no more than 4 weeks. You don't have more than 4 weeks, right? You can have less, but it cannot be more. So if you have at most, that means the greater number should be 4. You shouldn't have no more than 4. So that is less than or equal to 4. And we'll call that weeks. Pension is from age 65 and older. So age 65 and older means you're going to start at 65 and then age must be greater than or equal to 65. So that is what that would be. Greater than or equal to 65. A check is not equal to cash. That one is quite a bit more easier. Is not equal to. Which operator is that? So we have not equal to. So we say a check is not equal to cash. That's it for that one. All right, we're moving on. Next question. Consider the following algorithm. And this is the algorithm. And what we're doing again, we are looking for the different operators that we would have revised. Arithmetic, relational, and logical operators. Arithmetic operators deal with calculations. Relational operators compare, do comparisons, right? And logical operators, basically, logical operators allow you to combine statements that is true or false, right? So let's see. Let's look for arithmetic operators. Where do we see calculations happening? Here we see calculations happening, count plus 1. So this would be an arithmetic operator. Do we see any other? No. So an arithmetic operator here would be the plus sign. A relational operator, relational, it's doing a comparison. Relational operator doing a comparison, comparing values. Where do you see comparison happening? We see word. This variable word is being compared to a password. So this one would be a relational operator. We see here count is being compared to 3. So count is less than or equal to 3. That's a relational operator. So 2 relational operators happening. The not equal to and the less than or equal to. A logical operator. So a logical operator would be and, or, not. So logical operators are and, or, and not. And in this example, we see one logical operator here, which is and. Which of the following ways can an algorithm be expressed? Right? Algorithm, we say again, an algorithm is either pseudocode or a flowchart. Do we see any of that? Yes, we see it. So the answer would be B, pseudocode and flowchart. Different shapes of flowchart boxes are used to represent what? Right? We have flowchart, we have the decision box, we have the output, input, we have processing. So we look at this. Is it representing if then else? No. Initialize for loop? No. Compile debug? No. So the answer is D. Read the text on the left and answer the questions below. It's not on the left, but let's read the text. The following are steps to be followed in problem solving. We're getting another question, so this should be easy. We know the first step of problem solving. It says, which of the following sequence represents the correct order to be followed in problem solving? The first step of problem solving is always to define the problem. So we know that this would be number 1, define the problem. 3 would be number 1. Then after we define the problem, we propose and evaluate solution. So propose and evaluate solution. Then we determine the most efficient solution, we develop and represent the algorithm. And then we test. So which one would be the answer? There would be 3, 1. Which one have 3, 1? 3, 1, 2. 3, 1, 2, and the answer would be C. 3, 1, 2, 4, 5. Which of the following is a conditional statement? Conditional statement, branching again, and we go with C, if then else. The others are loops. Which of the data type is most appropriate for storing an average score? An average score can be decimals, so we're looking for something like real. Which of the following is not a looping construct? Loop allows you doing repetition, you're repeating some actions, which is not a looping construct. And we know while is a looping construct, repeat until 4, so the answer is C. Statements that closely resemble a programming language and are used when writing algorithms are called what? Statements that closely resemble a programming language and are used when writing algorithm. We call that a pseudocode, right? Which of the following statements would print cost if it is greater than 100? So we're looking for an arithmetic operator that says it is greater than. Greater than means greater than. Greater than. It is greater than. Where is that? C. If cost is greater than 100, then print cost. Read the text and answer the question. Consider the following algorithm, right? So this one we will be working this out, all right? So let's see if we can work this out, all right? We could do a trace table, right? So we could do a trace table and quickly answer this. So we have A, and we have B, right? We said the first line, A is 8, B is 5. This line says A plus B, so we have 8 plus 5 is going to give you 13. So A becomes 13. All right. The next line says B is now equal to A minus B. So A in this case is 13. So we're going to have 13 minus 5. 13 minus 5. And now B becomes what? 13 minus 5. B becomes 8. Right? Right, so we've done this step, we've done this step. We're moving on to this one. A is now A minus B. Yes, let's continue. So we're at this step where we're saying that now A is going to be 13 minus 8, and that is going to be 5. Right? I'm not seeing the answer here because A would be, sorry, the answer is there. A would now be 5 and B would be 8. So this would be the answer. Let's see, 13. Next. Read the text on the left and answer the question below. Consider the following algorithm. So let me see if we can zoom out a little, just a little. That's too much. See the entire instruction. All right. Read the text on the left. And we're not looking at the left anymore. We're just looking at the text below. Answer the question. Consider the following algorithm. Start. And this is the algorithm. All right. If this algorithm is run, what would be the output? Again, we can do a trace, right? So we start num equal 5, total is 0. So we have two variables really that we'll be capturing in this example. One is num, and the other is total. All right, bear with me on the writing. All right, so start with num being 5. First line num is 5. Total is 0. While num is less than or equal to 25, is num less than or equal to 25? Yes. So we're going to say now that num is now equal to num times 8, which is going to be 5. So this is 5 times 8. 5 times 8 is 40. Right? Next line, total is equal to total plus num. So total is 0 in this stage, and num is 40. So total becomes 40. We are going to go back to the top of the loop. Right? Is num less than or equal to 25? No. So we're going to exit the loop. Right? We'll come to the next statement. Print num total. So you should be printing 40, 40. The answer is not shown there. So the answer here should be 40, comma, 40. Right? None of these are the answer. All right, let's move on. A program which includes a command to divide a value by 0. You would have covered different types of errors, programming errors. You have logical error, runtime errors, and syntax errors. Right? So which one is the divide by 0? Divide by 0 is an error which would cause the program to crash. right? Which error is that? If you said runtime error, then you're correct, because runtime errors are errors that cause the program to run. So it will run, you know, but it will crash. When it gets to that line, it will crash. Next one. We're looking at this algorithm. Let's look at this algorithm. It asks us to read through the algorithm and complete the value of the variables in the trace table. Right? The trace table. What is this algorithm doing? Right? So let's read line by line. It starts with the value J being 5, L being 10, and total being 45. And we have a loop. While total is less than 75, as a condition, we're going to execute these steps, right? Total plus L. So what is total in this example? Total was 45, so we're going to add 45, we're going to add 10 to 45. So 10 to 45 would give us 55, right? Right? Next part, L in this example, this line, so we've done this line. L is now L plus J. L plus J. So J is 6 here. So we're going to have 6 plus J was 5. Okay. So J was 5. So J is 5 plus 10. 5 plus 10. 5 plus 10, 15. Right? L becomes J plus 1. J plus 1. L becomes J plus 1, which will be 6. L becomes J plus 1, which would be 6. I think there's an error right here. Right, this line, there's an error right here. This should be J. J becomes J. Right, there's an error right here. J becomes J plus 1, which is 6. Right? That looks like an error. Right? Next line, we're going to loop. Right, we'll go back to the top. Is total less than 75? Yes. So we continue. Total in this example was 55 in at this point. So now 55 plus L. What is L? 15. So 55 plus L, 15 plus 55 is going to be 70. And L would now be, so we've done this line. L would now be L plus J, which was 6. So L plus J is going to be 6 plus 15, which is 21. So L becomes 21. And we have J being, we're adding 1 to J, so J would now become 7, right? We're going to the next step. Next step, we're saying that now we're going up back to the top of the loop, right? Is total less than 75? Yes, it is less than 75. So we continue. So we have total plus L, which is going to be 70 plus L. 70 plus L is 70 plus 21. 70 plus 21, what is that? 70 plus 21 would give us 91, right? And L will now be L plus G, so we have 7 plus 21, right? Which should be 28. And that would be the trace for this, right? I hope you're trying while we're working on this. All right. Moving on, next question. What is printed by the algorithm? So we did the trace table. Now we need to say what is printed by the algorithm, right? It says now, if the total is greater than L, is the total greater than L? Yes, we're going to print the total. And what was the total? 91. The total was 91. So it would print 91. Give an example of a conditional statement used in the algorithm. So we look back at the algorithm. What is the conditional statement we saw? Conditional will give you options. Remember, if, then, else. So the conditional statement that we're seeing in this example is going to be this part. If, then, else. That's the conditional statement that we're seeing. So we see if, then, else. And we actually write out, we can write out the entire statement, right, for the answer, which would be this. Everything here would be the conditional statement. So we write out all of this to be the conditional statement, right? All right, let's take a break.